Today we're meeting with Simon Edwards to talk about some of the work he's been doing as part of the soil CRC projects. Simon's from UTAS and is an agtech innovation leader, and he's been working on a project which is the BANDICOOT. Thanks, Si.
Yeah, the BANDICOOT is a technology evolved from our smart shovel project, which we did with the CRC, where the goal was to, empower the grower with a tool that was farm ready that they could use. And when we started that project, we weren't too sure where it would lead, and where we ended up was with the BANDICOOT concept, which was to create a soil profiling tool that could be thrown in the back of the ute and used by a grower to simultaneously sample a profile and get compaction, moisture, salinity in an easy to use format, so that they could really build that profiling of areas of interest and there and then, not being reliant on complicated systems to get that data.
What was the need or driver for what started as a smart shovel but became the BANDICOOT? What was the industry or the problem you were trying to overcome?
One of the things we were trying to solve was to give that sort of much more localised, immediate capacity for measurement. It was to bridge the this lack of attention to compaction that goes on in terms of baselining and measurement when it's such a critical factor in agriculture, and obviously that requires moisture information as well for the two to fuse together. So that was sort of where we started. Grower focused tool, easy to use, giving good practical insights there and then. So if there's an area of interest, right, we can go and probe it a little bit like in the dig the dirt up and have a sniff and a look and a feel. It was that sort of trying to get tactile about it for the grower.
How did you overcome some of these challenges with the development of the BANDICOOT?
Yeah, so working with the growers to figure out what we needed to build was one thing, and then really starting from a simple systems architecture to make sure every component of the system was going to be robust and solid, and allow us to also develop in an agile sense the tool itself. So we, just simple things from the simplicity of the power system through to how easy it is to use all of those components. So once we had that information on board, we then were tasked as an engineering team as to how we're going to actually build it, how we're going to innovate to create what's become the most complex component and the hardest to build, which is the actual sensing tip, a tip that's resilient enough to obviously go into the dirt, but can give us real-time measurements very quickly, so that it only takes around 30 to 60 seconds to sample that profile to get your 5 centimetre incremental data, and we're getting a very rich data set as we go down.
And one of those challenges around the tip was obviously they'll take some wear and tear, but obviously the robustness of the device and the ability to replace those tips with time.
Yeah, that's right. So we had to create an architecture or a system architecture where that tip could be replaced and not be excessively expensive. Also using some other smarts around the, obstacle detection and things that where we could intelligently prolong the life of the tip by not trying to force it through a rock. Yeah, those sorts of things.
Yeah. In terms of those real world opportunities for the BANDICOOT and the benefits, what do you think will come of that?
Look, there are two main streams I see. I see a stream in terms of growers being able to benchmark their compaction and start getting a lot more paying that soil compaction a lot more attention. But to actually get those baselines and really start to make more informed decisions about how optimal that soil condition is for growing and planting and all of the processes that go on.
Yeah, so probably longer term seeing it almost being just one of those tools of trade that you'll have and can access on a regular basis.
Spot on. And at the back end, there are smarts there so that we're looking for that data to be accessible for their agronomists. So the system topology, whilst the grower might own the tool, that data can be shared up to their advisors and their agronomists as well, and form an integration with any of their fixed sensor probes they might have out there in the field as well.
What's next?
We're looking for commercialisation partners now to take that next step as we look to evolve, the first early adoption market and just get the tool out there being used. We see it as a really exciting program of work in terms of the R&D is not finished in terms of what this tip's able to do. So we believe that with some future research, we may be able to start to infer other soil properties because of the unique way that we actually do our sweeps and the tip work.
And it sounds like some of the grower groups are really excited about the prospect of bringing it into some of the long-term trials.
Yes, yeah, absolutely. There's a great interest there, and we've got some interest in a couple of irrigation projects that are going on as well, because it's a tool that doesn't exist. And at the moment, to do what we do with this tool, you need a dedicated penetrometer. You need to be able to do the soil moisture measurements, which aren't straightforward. And so really, it's a new paradigm of measurement, soil profiling.
Excellent. Thanks again, Simon, for the opportunity to talk about the Bandicoot.
Excellent.